Hey everyone, welcome to the Analytical Chemistry Educational Resources YouTube channel. My name is Dan Sykes, and over the next series of videos, we're going to be addressing the question, why on earth would I or anyone ever choose to be a chemistry major? Now, our discussion uses the chemistry major as a framework, okay, but much of what we're going to be talking about does cross disciplinary boundaries. It applies to STEM and non-STEM majors alike. Well, why is that? Well, your university degree, your university experience is really all about achieving the skills and competencies and pursuing the professional development opportunities that will allow you to become who and what you want to do and be. Okay. And many of those skills and competencies transcend disciplinary boundaries. Okay, so why me? Why listen to me? Why go through these series of videos with me? There's certainly people out there that are less monotone and more dynamic and maybe much more experienced than I do with respect to career counseling in STEM and non-STEM related fields. But I hope I can offer some unique perspective here. And why is that? Well, I have been an instructor for over 30 years. And in that time, I have taught over 16 different courses, 9 of which I've created or co-created. Now, this is not a full listing right here, but as you can see, I've taught through all levels of the chemistry curriculum and outside the chemistry curriculum as well. I've also taught in the forensic science program. I've taught environmental science courses, geoscience courses, and even an English course as well. So some experience teaching at multiple levels and multiple disciplines within multiple disciplines. I put this up there because I've also had some experience with summer camps, developing and teaching or directing summer camps as well. These camps are meant for 4th through 8th grade students, so I do have some experience working with younger children. I actually, even a very long time ago, was a substitute teacher for 6th grade, a long time ago. But I mentioned this as well because for these summer camps, the CSI summer camp actually is the precursor for the forensic science program at Penn State. And so I'm the co-founder of that program, both the undergraduate and graduate programs, and developed and created and guided the forensic chemistry option within that major for a number of years. The students within that program, under my direction and mentorship, et cetera, have won all the major awards in the forensic science discipline, and also within the chemistry discipline, and within essentially competitions here at Penn State as well. I've also served as the associate head for the chemistry undergraduate program here at Penn State, and where each semester we provide instructional services to about 5,500 students in 23 different lecture courses, 2,600 students in 8 different labs or lecture lab courses, all requiring about 140 teaching assistants, 14 instructional faculty, 44 graduate faculty, and 10 academic staff to pull that off. Now, that's a major operation. And so you might be thinking, well, Dan, I'm most interested in attending a primarily undergraduate institution, and that's okay. Again, you're looking for those skills and competencies, professional development opportunities, and you may be better served at a primarily undergraduate institution for that. And that's not an issue. But here at Penn State, we're actually a very small department. We only have about 160 students all told throughout all 4 years. We have about 40 students entering in as first year majors and 40 students graduating per year. We're one of the smallest departments for a major research institution in the United States. And that means that we have about a 1 to 4 faculty student ratio. So it also says that we have all the problems that a big research institution has in terms of departmental concerns and things like that, and undergraduate program concerns, but we also share a lot of the same concerns that smaller, primarily undergraduate institutions have as well because of our size. Okay, so I've also developed, as part of my research effort and mentoring students in research, over 20 years ago, I developed a small mobile instruments for laboratory enhancement program. And in this program, students build instruments from scratch. It's a passion of mine that one, we have to understand the tools that we use to observe chemical processes. These are fundamental to any of the measurements that we're making. And just because an instrument's on, it's going to give you a number, but it doesn't mean that number has anything of relevance to say to the chemistry that you're trying to observe. So you need to know something about the chemical instrumentation that you're using. Okay. And so I've used this as a platform for my research and getting undergraduate students involved. Now, what I found is that as students build these instruments, they learn not only the chemistry behind the measurements that are being made, but also the chemistry and physics associated with the measurement process itself. Okay. And it also then fosters student ownership of their program's curriculum. Why? Because they are building essentially instruments that work, and essentially the numbers that they're generating are essentially valid, real numbers, and compare with commercial instrumentation as well. And so we use these instruments that are built by senior level students in our lower level curriculum based courses. And so students are actively contributing to our the enhancement of our curriculum. That's great. And as part of this, then, students are building some sophisticated instrumentation. So the NMR probes that we build fit right up into commercial 400 megahertz instruments. We build cyclovoltammeters, fluorometers, colorimeters, Carl Fisher, which is a water measurement technique, conductivity meters. We have about 12 different instruments, not all of which are we have publications on. But we do have a number of these publications. We have about 10, maybe a little bit more student first author papers associated with this program. And over 20 institutions and organizations have taken those specifications that we have published and built one or more of these instruments to enhance their programs as well. So in addition to the SMILE program, that's not related to building instruments, but it's part of the SMILE program as a whole in terms of enriching a student's experience within their program. Students are active consultants on a number of projects that we have. And so I guide these students, mentor them through the real life problems that are given to us by industry, and they work as consultants on this. We write white papers associated with the work that we've done. We've performed work for some major chemical companies within the United States, some national labs, and even the Georgia Innocence Project as well. Okay, so I've developed and taught courses, so I have lots of experience at the individual course level. I have lots of experience at the programmatic level as well, including upcoming, we're establishing an integrated undergraduate-graduate program, of which I'll be the director here at Penn State. And if you've not heard of these IUG programs before, these are also known as 5-year programs, where at the end of them, a student will receive their bachelor's degree and their master's degree as well. Okay, so hopefully I have maybe a little bit of buy-in in terms of my experience at all levels of the curriculum, essentially a career devoted to my students to help them become who and what they want to do and be. Okay, so again, our questions are, what does the chemistry major look like? What is in the curriculum? What courses am I likely to be taking? What opportunities and experiences should the department be offering me? Because that's essentially what I'm looking for in my program. And then once I've obtained these skills and competencies and had these professional development opportunities, what can I do with a degree in chemistry? And this might be a concern that your parents share. Okay, so now the big thing here is that the undergraduate degree is not a commodity. It's not a loaf of bread that you're buying. Okay, it's an investment in your future. So you're not paying for your degree. I'm sure there are institutions out there that if you give them their money, they'll hand you a piece of paper that says you have a degree. So it's not a commodity. This is an investment in your future. Okay, you're buying access to expertise and resources and professional development opportunities. That's what you're buying into. Okay, so whether your investment pays off then really is dependent upon you and whether you're making effective use of those resources and expertise and professional development opportunities. All right, so now many of the examples that we'll be looking at over the next series of videos are essentially examples related to the analytical chemistry program here at Penn State that I've essentially developed. So you may not have heard of analytical chemistry before. It's one of those traditional disciplinary areas within chemistry that we tend to still define ourselves as being a part of one versus another. But you'll quickly find out through our videos that today chemistry really crosses those disciplinary boundaries in every single way. There's not a single research project that is being conducted now or position in industry that is not interdisciplinary or even in fact multidisciplinary across even majors, right? Biological sciences, chemical sciences, other life sciences, etc. Essentially the real world problems of today really take an interdisciplinary or multidisciplinary approach to solve. Okay, so we'll be essentially talking next time, what is analytical chemistry? How does it fit into the curriculum? And what is the future of a person with a focus on analytical chemistry? But remember, the goal here is not to train analytical chemists at all. It's just using my background as an example, my background in analytical chemistry as an example of a paths through the chemistry curriculum and what you can do with the skills and expertise that you developed as part of that chemistry curriculum in the future. Okay, so until next time, take care, and we'll see you again soon.